Hey, after a long hiatus, I am now back. So, today we are going to look at a TMUA question from 2023. And this question combines geometric series, inequalities, as well as a tiny bit of probability at the end. So, let's have a look at the sequence that we're given. We're given a series 4 plus 8k by 7 plus 16k by 49 plus so on and so forth. So, right off the bat, just by looking at the first four terms, we know that 1, it is geometric, and the common ratio is 2k by 7. 2, that this is an infinite series, because you're given the nth term, and the series keeps on going. 3, you're now asked to find the probability that the value of s is a finite number greater than 3. So, if you are getting a finite number, this means that the sum to infinity exists. In other words, it is finite. And this occurs when the common ratio is less than 1, the absolute value of the common ratio. So therefore, this has to be true. So always keep that in mind. Furthermore, we know that the sum to infinity is equal to the first term divided by 1 minus the common ratio. First term, 4. Common ratio, 2k by 7. We need to solve the inequality as infinity is greater than 3. So, multiply both the numerator and the denominator of the fraction with 7. Notice that I did not multiply the right hand side with 7, because effectively what we're doing is we're just multiplying the top and the bottom of the fraction. The value of a fraction does not change. Now we need to solve this inequality. Since we do not yet know the value of 7 minus 2k, we are going to multiply both sides with 7 minus 2k squared. Because a squared number is not negative, because we're all talking real numbers here. Shove everything to one side. Factor it out. You're now down to a basic inequality. You gotta be very careful with this. I hate seeing two negatives, so I am going to factor the negative 1 out. This bracket now becomes 7 plus 6k. I will then now apply this guy to this bracket to make it 2k minus 7 times 6k plus 7. This is the inequality that we have to solve. By now, you should know how to solve a quadratic inequality. The roots of the quadratic are 7 by 2 and negative 7 by 6. Your sketch need not be accurate. The parts that you're truly interested in are the values on which this is true. So this is true when k is between negative 7 by 6 and 7 by 2. Does these values meet the condition that we have established? Yes, because for this to be true, we can just quickly solve the inequality. Everything we've found here falls inside this interval. So we're good on that front. Now, we know that k is randomly chosen from a range from negative 5 to 5. So, These are the values of k that we can choose. These are the values of k's that we can accept. Recall that we can only accept integers. So, out of the 11 values that you're given, you can take 5 of them. So the required probability is going to be 5 by 11. And this is the end of the question.